Have you ever wondered what happens when you press the Apple Pay or the Google Pay button on your phone? Like, how does a merchant actually charge that card, or how do they use that card that's in your phone to perform the transaction? Today we're going to be exploring that. You as a consumer, you have your card. This card was issued by a bank or a credit union or some neobank, some service that can give you access to a credit or a debit card. You take this value and you add it into your phone. And that could be you scanning it, or you could type it in manually, or you could use a push provisioning service from that issuer's app. So there's a few different ways. Point is, it gets into your device. When you add that into your device, Apple is going to reach out to the network and generate a network token for that card. And then they're going to tie that network token to the device. This is called a DPAN, or a device primary account number. So this DPAN gets loaded into the device, and when you're on a merchant application, there will be a little button that says pay with Apple or pay with Google, or same thing for the other wallet providers. When you press this button, they are going to use this DPAN and they are going to generate a cryptogram for that transaction, for that customer initiated transaction, and then they encrypt everything. And there's technical details we can get into on how it gets encrypted, but the point is that that data hits the device in an encrypted format and it gets sent to the merchant server. So from here, the merchant server now has access to an encrypted Apple Pay or Google Pay payload, and they want a way of decrypting that value. So enter VGS. So VGS is a way of decrypting the values that have come from the device without exposing the values to the merchant. This makes it far safer for the merchant to interact with these credentials. The reason that this is different than other network tokens, where we've talked about before, is network tokens, when they're issued by VGS, will be tied to a merchant. When a DPAN is issued, it is tied to the device. So the same DPAN will be used at multiple merchants, which is why customers don't want to be exposed to that data. If you have an iPhone and an iPad, they will have two different DPANs associated to those devices by default. This is a way for Apple to be able to store your payment credential in the device without storing the original card number. So Apple is not in PCI scope long-term because they are getting rid of the card number. They're just storing the DPAN. The merchant sends the encrypted values over to VGS, and VGS will decrypt those values and return them to the merchant so that they can use them in a transaction. Included in this payload would be the network token, or that DPAN, the cryptogram, along with any of the transaction information like the amount, things like that. The merchant has access to all the information that they need to make a payment with that Apple Pay information, or with that Apple Pay, Google Pay, whatever. And they send this over to the PSP, and then the PSP will forward it onto the network, and then the network will forward that onto the issuer, and everything gets authorized. Now, in the same way as other network tokens, if this is a customer-initiated transaction in the context of Apple Pay, it means that they are pressing that Apple Pay button again. Then Apple will re-encrypt that DPAN, regenerate a cryptogram with the networks, and send it through the merchant where they can decrypt it using VGS, and then they send it through to the PSP network and so on. So VGS allows the merchant to store that data from the device on file so that they aren't exposed to that data, and then they can use it in recurring transactions. The difference here between the way it works with VGS versus the way it works in the past is, historically speaking, the PSP would provide this Apple Pay service, and then anytime you wanted to process Apple Pay transactions, it would be behind the gate of that PSP. What this meant is that if that PSP was down, or if you wanted to move away from that PSP, you were in trouble because you couldn't perform Apple Pay payments for all of your cards on file without using the PSP's token. And so what VGS allows you to do is store that DPAN, get access to that DPAN, route it to PSP1, or you can route it to PSP2, and you can orchestrate the Apple Pay payments the same way you would orchestrate the card payments or your other network token payments. Fundamentally, this is giving you more power because you are not locked into one PSP, so you can negotiate better, and you also are more resilient in the case that PSP1 goes down. You can fail over to PSP2 without any downtime. So we've explained how the wallet works with your phone. For a merchant, this is beneficial because it's a great checkout experience. It's easy to pay. And for a consumer, this is great for the same reason. It's an easy to use experience, so everybody wins here. The consumer can load in their card, they can quickly transact. The merchant can store their payments on file for any recurring payments. And then the merchant, the processor, the network, and the issuer, they can all be sure that this is an authenticated transaction from Apple Pay.